Okay, so this video is going to look at correlations. There are two types of correlation, the Pearson's correlation coefficient and the Spearman's rho. Which one you choose will depend on the type of data you have. We'll be covering both of these in this video. So this tutorial will begin with the Pearson's correlation coefficient and then move on to the Spearman's rho. I'll also show you at the end how to plot the data in a simple scatter graph and also how to write up the results in APA style. So, the Pearson's correlation. This is also known as Pearson's R. This measures the linear correlation between two variables. The variables must be measured on an interval or ratio scale to conduct this analysis. Essentially, what the Pearson's correlation is determining is whether there is a linear relationship between two variables, and if so, what direction and how strong is this relationship. So, let's look at some data. So here you can see my SPSS data file. Got four variables here, as you can see labelled in the variable view. Two of them are scale, two of them are ordinal. So we're going to look at this scale, these two scale variables first. So what we've got here is some data where participants were asked to record how many hours they spent revising for an exam and then their final grade. You can see that we've got 15 people have taken part, we've got 15 rows of data, and as I said, I've got two variables, the number of hours revised and the student's final grade. I'll ignore these two for now and come back to them later. So what I'm interested in is whether there's a relationship between these two scores here, between the amount of revision somebody did and the grade that they ended up with. And then if there is a relationship, which direction is that relationship in? So let's run the Pearson's correlation to find out. To do that, it's really simple. You click on Analyse, Correlate and Bivariate. And then you'll see we've got this box here. All we need to do is put in the variables we're interested in. So we're interested in time spent revising and final exam grade. And you can see here that the Pearson's has been ticked already, so that's fine. We leave that as it is. And we click OK. So this is really simple output. There's just one table to read and interpret. It's also mirrored, so in effect we actually only have to read half of this table. You can see you've got time spent revising as the row titles and also time spent revising as the column titles. So actually we only need to read half of this table, which I'll explain to you now. So you'll see here we have the correlation. So this is the Pearson's correlation. This is our R value and it's this value here. We also have the significance. This is our P value and that's here. And then N, which is the number of participants in our group, which is here. What you'll see is this is actually repeated twice. So we've got the time spent revising and the final exam grade. This is the correlation. We've also got the correlation of final exam grade and time spent revising here. So we can actually ignore one of these rows in this case. So we'll just focus on this top row. What you'll see as well is time spent revising has actually been plotted against itself. And as you'd expect, there's a perfect correlation. So we've got a 1 here. There's a perfect correlation there. We can also ignore this box. The only one we're interested in at the moment is this box here. These are the results that we're interested in. So looking at this output, what we can see is actually we've got quite a strong relationship between these two variables. And that's told to us by this R value here, so it's 0.789. This tells us there's a strong relationship between the two variables. So this slide here, this explains to us what these R values actually mean. So you can see it in the tally along the middle. So 0 means there's no relationship between the two variables. A 1 would suggest a perfect relationship, and a -1 would also suggest a perfect relationship. And then you've kind of got it going between weak, moderate, and then strong. So if you look at our R value, which was 0.79, you'll see that's quite a strong positive correlation we've got between these two variables. So what does that mean? Well, it means that as one value increases, so does the other. So in this case, the more hours revision done, the higher the student scored in the test. So that's the Pearson's correlation. We'll now move on to the Spearmans. So the Spearman's rho, which is also known as the Spearman's rank order correlation, is used when you have ordinal data. It's a non-parametric equivalent to the Pearson's correlation. So looking at this data here, we have the same 15 students, and this time we're interested in their ranking, so their ranked performance in their classes. you'll see on the variable view that this data is different. This is ordinal data for these two variables. So what we've got is we've got students ranked in their order of performance in their stats class, and then we've got students ranked in the order of performance in their drama classes. What we're interested in is whether there's a relationship between these two rankings. So to work that out, we do exactly the same thing. We click Analyse, Correlate and Bivariate, and then take those two variables out and put in our two variables that we're interested in, so that's the stats rank and the drama rank. Now what we need to do is deselect the Pearson and select the Spearman. So we just tell an SPSS, instead of doing the Pearsons correlation, we're now doing a Spearmans. And then click OK. And then you'll see in this output box here, so it's this bottom one, you'll see we now have the non-parametric correlation. As you'll see, this output's exactly the same as before, so you interpret it in the same way. Again, with a strong relationship between the variables, you can see here it's 0.85 is our correlation, so this tells us it's a strong relationship, but this time we've got this minus sign by our result. This tells us that the correlation is a negative one. So if we have a look back at the slide quickly, you'll see here negative correlation means that as one variable increases, the other one decreases. So back to our output, which is here. We've also got the significance level, so we know that this correlation is a significant one we wouldn't expect to occur by chance. So another way to look at correlations, and one really good way to look at data, is actually to plot them in a graph. So I'll show you quickly how to do that as well. If you click on Graphs and Chart Builder and then just click OK, you'll get these two boxes up. What we want at the moment is a scatter or dot. So we click on that, so scatter dot. Then if you click this top left one, simple scatter, and double click that, what that then does is brings it up into the preview panel. Then from there you just need to drag the variables that we've looked at into the X and Y axis. So the first one I'll do is the data from the Pearsons correlation. So the time spent revising, I'll put that in the Y axis, and the student's final exam grade I'll put in the X axis. If we click OK, then the graph will appear. As you'll see, this was our positive correlation. You can also add a line of best fit to the data. If you click Elements and then Fit Line at Total, see it's put a line of best fit in for us, so we can close that and that line of best fit will stay. We'll also do a graph for the Spearmans data, so if we click Graph Chart Builder, OK, and then we'll just take those ones out because we don't want those anymore, and then pop in the new data. So we'll put the stats ranking, so the ranking of the students in the stats class on the x-axis, and then the drama rank in the y. And click OK, and we can have a look. What you can see with this graph is it's quite different. This represents a negative correlation. As you see, one variable is going up, so as the stats ranking is going up, the student's drama ranking is actually going down. So the student who has the highest ranking in their stats class here actually has the lowest ranking in their drama class, and vice versa. Finally, I'll show you how to write these up in APA style. I'll just pop this slide up. So this is kind of a guide of how to do it. I'd always recommend checking the guidance of your assessment and the APA guidance as well, but this is quite a simple format that should cover all the information required. So basically the results of and then name the test, so whether that's the Pearsons or the Spearmans row, shows that there is a significant positive or negative linear relationship or no significant linear relationship between variable 1 and variable 2. Then you've got your write-up of the statistics there as well. So to write up, say, the Spearman's test that we just did, so this was the ranking of students in their stats and drama classes, you would report it in a similar way to this. The results of the Spearman's row test shows that there was a significant negative linear relationship between students' ranking in their stats class and the ranking in their drama class. And then we've got the stats written up here. So as you'll see, we've got the Spearman's row symbol there, so it's the R and the small s, that stands for Spearman's row. Degrees of freedom in brackets. In this case, the degrees of freedom is calculated as the number of participants, so n minus 2. And then equals, and then this is where we've got our Spearman's row value, so it's 0.85, but remember that was a negative, so it's minus 0.85, tells us it's a negative correlation, and then the p-value, p is less than 0.001.